Hello, this is Mr. Montgomery. This video is geared toward my physical science 2 lab students. We're going to look at some examples of isotopes and dealing with their percent abundance. I put a link to these examples down in the description below. In these examples, we're going to use silicon as our element. Now, silicon happens to have 3 different isotopes that are stable: silicon 28, 29, and 30. When you see the name of an isotope, this number right here is its mass number, which means the mass number is the number of protons plus the number of neutrons. Well, silicon, when you look at your periodic table, silicon is atomic number 14. So every single atom of silicon must have 14 protons. That's what makes silicon silicon. And you see that when you write out a symbol. So silicon always Si. It's got 14 protons. And in this example, its mass number is 29. So these symbols are always the element that you find on the periodic table, the atomic number, and the mass number up here on top. So this last one, this silicon 30, still has 14 protons, but a mass of 30. Now, figuring out the number of neutrons. Well, the number of neutrons is always going to be the mass number minus the atomic number. So this, again, this 28 means if you add all the protons and neutrons together, well, then if we're saying, okay, we have 28, 14 of those are protons, well, that means you got 14 neutrons. All right, same way here for silicon 29, 29 minus 14, there's 15 neutrons. Silicon 30 is 30 minus 14 is 16 neutrons. But again, if you add up the protons and neutrons, you get the mass number here. And what makes an isotope is an isotope means that you have an atom that can have different numbers of neutrons. Same number of protons. All right, these other values over here, you're going to get these from the lab experiment, from the simulator that you use. But if you have different numbers of neutrons and different mass numbers, those atoms are going to have slightly different masses over here. Okay, just about 1 extra AU when you add an extra neutron each time. But these isotopes don't all occur at the same rate. In this example, silicon 28 is by far the most common silicon isotope. Over 92% of all silicon is silicon 28. About 4.5%, 4.685% silicon 29. And then a little bit less, just a little bit more than 3% of all silicon is silicon 30. So in this next example, if we had 5,000 silicon atoms, how many of those would be number 28, number 29, number 30? Well, 92.223% of all silicon should be number 28. And so the way we make this calculation is we're going to say, okay, we have 5,000 atoms, 92% of them are silicon 28. So I'm going to take this 92% and I'm going to turn that into a decimal. Anytime you want to turn a percentage into a decimal, you're going to divide it by 100, or you're going to move this decimal place 2 places here. All right, so I'm going to multiply 5,000 times 0.92223. And so if I had 5,000 silicon atoms, most of them are silicon 28. Right, 4,611. Now you can't have a fraction of an atom, that's not possible. So I'm just going to round it down right here. All right, for the next one, I got 5,000 times this percentage. Okay, now I got to move this decimal place twice, so don't forget that there's going to be a 0 in front of this 4. I divided this by 100. And so 5,000 times 0.04685. That means I'd have 234 atoms of silicon 29. And then lastly, for number 30, 5,000 times this time 0.03092. Again, divided that percentage by 100. So 5,000 times 0.03092. That one, I'll round this one up because it's 0.6. 155 atoms. Now, if you look, this has to add up to 5,000 atoms total. You can't have more than 5,000 silicon atoms if that's how many you had to begin with here. So I hope these example problems have been helpful to you. If you need more help, feel free to reach out to me. Again, I'll put links to the documents down in the description below. But y'all have a great day.